take a look at this balancing question right here. If we look, it looks like our sodiums and our iodines are balanced, but our oxygens aren't. We have 3 oxygens there for every 2 oxygens here. The lowest common multiple between the 2 is 6. So if we times one by 3 and the other by 2, we'll get 6. So if I put a 2 there, 2 times 3 is 6. And if I put a 3 there, 3 times 2 is 6. Yay! But now that makes us have too many sodiums and iodines. But if I put a 2, I'm balanced. Okay, you're also going to have mole-to-mole questions. This question says, for the balance equation, how many moles of oxygen will react with 4 moles of carbon dioxide? Okay, so we have 4 moles of carbon dioxide. It tells me that's what I have. So this is my given. What I'm being asked to solve for, how many moles of oxygen, that's my question mark. That's my required. So my ratio is always R over G. So I'm going to go 4 mole times required, which is 6, over given, which is 4. Always draw an arrow to where you're going. That's your required. That goes on top. Times by where you're going, divide by where you've been. 4 times 6 divided by 4 is 6. 6 mole. Okay? All right, now there's 2 more questions on there. For the balance equation shown below, it's the same one. How many moles of water will react with 3 moles of carbon dioxide? Well, what do we know? We know 3 moles of carbon dioxide. We've been given this. That's our given. Okay, how many moles of water? We don't know. That's how many moles of water. That's our required. We're going to the required. We always times by R over G. So we go 3 mole times by the coefficients, 5 over 4. 3 times 5 divided by 4 gives me 3.75. Okay. Then there's a tough one. If we're going from, this one's asking for mass, so it's a little bit tougher. Okay. So it says we have 3 mole of this substance. Okay. 3 moles of that substance, and it's asking for grams. What goes with grams? Molar mass. Mass and molar mass goes together. So this is one of the tougher ones where we have to calculate the molar mass of carbon dioxide. For these, a mole to mass question, we have to go through a couple steps. First one is we have to write everything down. Okay. And that includes calculate molar mass for the mass. Okay, so the substance we're solving mass for is carbon dioxide. Carbon dioxide is CO2. So we have 2 oxygens, which are 16 each, and 1 carbon dioxide, which is 1201. Our molar mass then is 4401 grams per mole. That's our first step. Second step, find moles of required. Awesome sauce. So we got to find the number of moles of the required. So this is now our required because we're trying to solve it. That's our given. So we got to go R over G. So we're going to go 30 mole times our R, which is 4, over our G, which is 1. Right? Remember the where we're going? That's the 4. Where have we been? Well, it's a 1. 4 over 1. So we have then 12 mole. Okay, we're not quite done. All right, so third step. Let's move this down here. Third step is find mass using molar mass formula. Okay, so number of moles is mass over molar mass. We got to solve mass, right? That's what the question wants. So we're going to times both sides by molar mass. So when we rearrange this, mass is equal to number of moles times molar mass. Okay, well, did we find out how many moles? Yep, 12 moles. And do we have the molar mass? 4401. And when we multiply that out, 12 times 4401, we get, well, it's a pretty big number, 528 grams. Okay, so this last question's a little bit tougher, but because you're going to be able to do this open book, I'm pretty confident you can follow the procedure and get those questions right tomorrow.